for tonight, pages 316, 317, evens only. 316, 317, evens only. Nice. All right. Our objective for today, I can factor polynomials. I can factor polynomials. By now, we don't need a fair model because we know what polynomials are, yes? Studying over the definition for polynomials without looking at your notes. Very good. Monomials, or some or difference of monomials. Examples, non-examples, and hashtags. Yes, we have those? Yeah? All right. So, as we've been doing work, I still get some stares from some of you in regards to some of the vocabulary I've been using and some numbers that we get from whatever we're doing. Some of you are like, I can see you verbalize at your spot by yourself. You're like, how did they get that number? Believe it or not, I can read lists. So, not that I'm a Jedi master. So check this out. So I'm going to revisit a concept known as greatest common factor. Now some of you are going to have flashbacks to Frank Wright, Mr. Sanchez and all that, right? So when we cover this or revisited this, I said, we're going to find the greatest common factor between two numbers. But before we begin, I said we need to know the definition of each of the terms presented. The first term, what is a factor? Two or more numbers that multiply. Once again, a factor is two or more numbers that multiply. Okay, I got that, Mr. Q. All right. Let's think about the factors of 24, pairs of factors. What are pairs of factors? Two or more numbers that multiply. So in this case, only two. What are they? 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then they repeat but backwards, yes. And you don't need to copy this, you're just paying attention. The factors of 18 are 1 times 18, 2 times 9, 3 times 6, and then they repeat. So what are all these called? They're called factors. What are all these called? Factors. Well, let's start now going to this word, common. What does that mean? That they both have the same. So what factors do both of them have the same? Well, 1, 2, 3, and 6. However, the last word, greatest of all those. Which one's the greatest? 6. Okay, so now what do we do with the greatest common factor? We use it to find the other factor. Or in other words, we use a different term called factoring. What does the word factoring mean? It means dividing. Factoring means dividing. So I'm going to use the GCF, which is the greatest common factor. That's one factor. To find the other factor, I'm going to do what? Factoring, also known as dividing. What is 24 divided by 6? 4. Let me use my GCF over here also. Factoring, 18 divided by 6 is 3. So now these are my factors, these are my factors. That's how we use the greatest common factor, also known as GCF. All right. So far so good? But what if I gave you this? All right. First, I need the factors of 18. 1 times 18, 2 times 9, 3 times 6. Factors of 12. 1 times 12, 2 times 6, 3 times 4. Is that it? All right. And then factors of x to the fourth. X times x times x times x. Factors of x squared. X times x. Do you agree that all these are factors of this one? Yes. Do you agree that all these are factors of that one? Yes. So, looking at the numbers first, which is our greatest common factor? 6. Okay. Now looking at the variables, which is the greatest amount of variables that both of them have in common? 2 variables, this one and this one. So that is written as x squared. Okay, so to find my other factor, what do? Factoring, what does that mean? Dividing, all right. What is 18 divided by 6? 3. What is x to the 4th divided by x to the 2nd? X to the 2nd. If you don't see it, write it out. What happens to the exponents? We subtract, and that's how we get that. Common factor again. How do we divide? 12 divided by 6 is 2. X to the 2nd divided by x to the 2nd is 1. 1 times 2 is 2, and we're done. If you don't see it, x to the 2nd, x to the 2nd is a giant 1. And that's how you use the GCF. Now we're on the same page? All right, good. Copy this one. Example 1. I'm going to give you some mini steps to follow for each of these processes in regards to factoring. Step 1, standard form. Step 2, GCF. Step 3, factor. And simplify. If you follow those 3 steps, you'll be fine. All right, let's do it together. Let's check. Is this in standard form from highest to lowest degree? Yes. Check for GCF. Other than 1, is there a number that divides both terms? No. So I'm starting with the numbers first. Next, is there a variable that divides both terms? Yes. Which one? X. All right. That's going to be our GCF. So therefore, 2x squared divided by x leaves us with 2x. Negative 3x divided by x, that leaves us with negative 3. What we just did, we used the GCF to factor. Let's double check to see if we can factor now inside of here. Can we do anything else in here? No. If we can't, then we are done. These are our factors. But make sure at the end you check again for factoring. We good? All right. Some of you are like, Mr. Q, this is a piece of cake. Okay, good. See how you do with that one by yourself? Copy that and go. All right. I heard some of you say the GCF is 6y. Hands if you got that. That is correct. Here goes the process again. Is it in standard form? Yes. I'm going to check for GCF. Is there a number first that divides both terms? Yes. 1 and 1. How about 2 and 2? Yes. 3 and 3? Yes. 4? No. 5? No. 6? Yes. So the greatest one is 6. Now let me go to the variables. Does each term have at least one y? Yes, there it is. How about 2 y's? Nope, just 1 y. And we're left with y plus 3. Factors. And have you got that? Okay. Y'all ready? Okay, put on your seatbelt because it's going to go cranking it up a notch. Yes? Here we go. Copy this one. Example 1 super cube. Negative 3m minus 3m squared plus 3. All right, let's do this one together. Step 1, everyone. Is it in standard form? No, we need to rewrite it. So what goes first? Negative 3m squared minus 3m plus 3. Step 2. GCF, do we have a number that divides each term? 3. However, look up please. Whenever you see a subtraction or a negative sign on the first term, factor it out with the GCF. Next, is there a variable on each term that we can factor out? No, so that would be our GCF, and let's see what we have left. Negative 3m squared divided by negative 3, we're left with m squared. Negative 3m divided by negative 3 is positive m. 3 divided by negative 3 is negative 1. Step 3. What was step 3, everyone? Factor. Does this look familiar to factor? Yeah. What goes on top? Negative 1. What goes on the bottom? An invisible 1, so it's 1. So look at the factors of negative 1. Negative 1 times 1. That's it. Could we add those to give us 1? No. Subtract them to give us 1? Some of you are like, I don't know. Well, negative 1 plus 1, 0. Negative 1 minus 1, negative 2. Nope. So then we're done. Factors. Once again, check to see if it's factorable. If it's factorable, factor it. If it's not, it's done. Okay? Yes? Good question. Copy this one. See how? All right, step 1, everyone. Standard form, is it in standard form? Yes. Step 2, GCF, is there a number that divides each term? Yes, 1, 1, 1. How about 2? Yes. How about 3? No. How about 4? Yes. Anything else? No, that's the greatest one, so it's going to be 4. And what does that leave us with? X squared plus 3x plus 2. And last step, factor and simplify, yes? What goes on top? 2. What goes on the bottom? 3. Let's see. Someone asked Mr. Yu, what if we have a different number and it does work? Well, let's find out. What is factors of 2 that add up to 3? 2 and 1, and I'm going to write 1 and 2. What do we do with that, Mr. Q? Well, now we're going to rewrite this. Bring down the what? X squared. And then instead of writing what? 3x, what do we write now? Plus 1x plus 2x. You bring down the last term, which is plus 2. Does this look familiar now? Yeah. What do we do from there? Factor by grouping. That is correct. Group. GCF for these two. X, we're left with x plus 1. GCF for these two. And we're left with x plus 1. So my factors are x plus 1 and x plus 2. Now, I'm not done. Like I told you guys before. From now on, GCF is your BFF. Don't forget them. These are our factors. You're like, Mr. Q, thank you. I don't have a BFF. Well, there you go. GCF is your BFF. No? Never mind. All right. No, there's no lone wolves in here? No? Yeah. Never mind. All right, show me your parents how complete you are with this so far. Yeah, we got this, yes? Can I get up a notch? All right. Woo! Copy that and go. See if you can do that like in 40 seconds, something like that. Yep. It's like, really? And then I'm going really slow and I get to the stop and they get there at the same time. To the red light. Anyway. Alright, TCF everyone. -3, that is correct. Y squared plus 4y plus 3. So far so good? Factor, 3, 4, product, sum, 1 and 3 or 3 and 1? 3 and 1? Okay, 1 and 3. Alright, so then we rewrite this. Y squared plus 1y plus 3y plus 3. Group. This is y plus 1 plus 3, y plus 1. Factors are y plus 1, y plus 3. Don't forget your BFF. -3. These are my factors. Hands, have you got that? Yeah, show me if what's happened to you all with these. Yeah, we got this. Crank it up a notch. Woo, let's go. Copy that one. Yeah, I reel you guys in. It's like, here they come. Here they go. Same process, guys. Don't freak out. Just polynomial. Going down the street, like Donut Avenue. Somebody calls you on the alley. Polynomial. You can finish that by yourself. Copy and go. All right. Is it in standard form? Let's see. 4, 3, 2. Yep. GCF, I heard 4. That's one of them, yes. Yeah, the number 4 divides all the terms. What else does each term have? Y squared, that is correct. So, that's my GCF. So, 4x squared, y squared divided by 4y squared, we're left with x squared. If you don't see it, here it is, divided by 4y squared. This is a giant 1, this is a giant 1, and I'm left with x squared. Next, plus 32 divided by 4 is 8. Y squared divided by y squared is a giant 1, and we're left with x. 60 divided by 4 is 15. Y squared divided by y squared is 1, so we don't need to write it. Factor, product, sum, factors of 15 that add up to 8. 3 and 5. Yada, yada, yada. Factors at the end is 4y squared. What else? X plus 3, x plus 5, or x plus 5, x plus 3. These are my factors. And we got that? Okay, good. Yeah? Okay. Copy this one. Now, once again, we've already done all these. Use the force. Luke. Let's see. Step 1, everyone. Standard form, yes. Step 2, GCF. Is there a GCF? No, other than 1. So step 3, we what? Factor. But wait a minute. That's your cube. This one has a 2 right there. What do I do with that 2? Multiply it times the last term, and that gives us 24. Middle term, 11. Yeah? And then from there, everything's good. Factors of 24 that add up to 11? 8 and 3. So we rewrite this, bring this down. 2x squared Instead of 11x, I'm going to write 8x plus 3x. Bring down the 12 and group. GCF for these two is 2x. We're left with x plus 4. GCF for these two is 3. We're left with x plus 4. Factors are x plus 4, 2x plus 3, and these are my factors. So we got this, yeah? All right. Don't copy this one. Look up, please. Let's see if we got the process. Step 1, standard form. Step 2, GCF. Is there another GCF without 1 being 1? No. Factor. What goes on top? Down, 6, product, sum, 3 and 3. 9x squared plus 3x plus 3x plus 1. Group, GCF is 3x, 3x plus 1. GCF for these two. 1, 3x plus 1. Factors are 3x plus 1 and 3x plus 1. What's another way of writing that? 3x plus 1 squared. We got this, yes? All right. Copy that one. And you should be able to do this one, yeah? Okay? 30 seconds. Copy and go. All right, let's follow the process. Step 1, standard form? Yes. Step 2, GCF other than 1? No. Step 3, factor. Look, Mr. Q, but now there's 4 of them. How do I factor? Wait a minute. By grouping. Let's go. So, GCF for these two, x squared, x plus 2. GCF for these two, 3, x plus 2. My factors are x plus 2, x squared plus 3. Can I simplify this anymore? No, it's not a difference of squares, so I'm done. Factors. And if you got that by yourself. Okay, good. Yeah. Yeah, your noodles should be like, all of a sudden, wait a minute. I think I know this. Yes, we've been doing this. All right. Ready? Here we go. Copy that. Remember, follow your process. Follow the force loop. Copy that and go. Let's see. Is it in standard form? Yes. GCF. -2. That is correct. That leaves us with x cubed plus 3x squared minus 2x and minus 6. Is that correct? Can we factor this? How do we factor it? By grouping. Yes. Very good. So GCF here is x squared, x plus 3. GCF here is -2, x plus 3. My factors are x plus 3, which is here. What's left? X squared minus 2. Let's look at this. Is this a difference of squares? No, 2 is not a perfect square. And don't forget your BFF. -2, and these are my factors. Hands, have you got that? Okay, good. All right. How we doing? Good? Yeah? All right. So I think we got the basic stuff out of the way. All right. What's that? Go ahead, Cindy. Yeah, what? The basic stuff, yeah. So yeah, we've been talking about common patterns. And what were the 3 common patterns I gave you? These, yes? Is that correct? And you already have these. Now, hint, for, not hint, note and advice for those of you that are going off to college. If you ever go to a class, and by the way, most of the courses at universities, they usually don't take attendance. You show up and take your notes and study and stuff. So if you go one day and the teacher gives you this, you go a second day and are you going to write that down again? No, you already have it. What would you write down? Anything new that is added to stuff like that. Does that make sense? Because some of you are so used to taking notes of everything, and guess what? You start missing the main idea of the lesson. So try and get your brain used to just adding to the notes that you have. Does that make sense? Am I talking crazy over here? Yeah? All right. So these are identities. However, these have names. You don't have to write this down. The names for these 2 are known as perfect squares. Why are they called perfect squares, Mr. Q? Well, because this is telling us to square this to get this. Or let me use numbers so you guys can see it. If I do 4 squared, what is 4 squared? 16. The 16 is known as a perfect square. That means this is a perfect square and this is a perfect square because we got it by squaring these. Does that make sense? Yes, Mr. Q. All right. This one is not a perfect square. This one's called a difference of squares. Why is that, Mr. Q? Because difference implies subtraction. Squares implies that whatever's beside that are squares. Let's see if it's true. Can I take the square root of this? Yes. Square root of that? Yes. That's how I can find out if they are squares. So once again, difference of squares. But I said there are more patterns. So if that's true, look at this pattern. What would you call this? Tell your neighbor, please. Very good. Difference of cubes. Does it look like a difference? Yes. Do both of them have cube? Yes. If that's true, what would we call this? Sum of cubes. And what is the pattern for this, Mr. Q? That is always going to be the common pattern. This is the common pattern. You're like, how do we get there, Mr. Q? We can multiply it out, but at the end we end up with this. What is the common pattern of this? This. Now, what do you need to copy from this slide? Tell your neighbor. The last 2, copy those, please. Copy that. Now some of you are like, Mr. Yu, why do we have to copy this? Well, because tonight's home plate is going to have a couple that look like this. 8x cubed minus 27. You're saying that kind of looks like these, Mr. Q, but not really. Well, how can I rewrite this to make it look like that? Let me think. One number times itself 3 times, that's what cube means, gives me 8. 2, and this is x, so I would write 2x to the 3rd power. Minus. What number times itself 3 times gives me 27? So I would be 3 cubed. Does that look like this now? Yes. So that means, Mr. Q, is that, so what you're saying that now I can use this pattern to factor this? Yes, that's what I mean. So what would I write instead of x minus y? What do I write now? Very good. 2x minus 3. Does everybody see that? Instead of x only, now I have what? 2x. Instead of y, what do I have? 3. What else? Parentheses. X squared. What was x now? 2x, so I write 2x squared. Plus, what is next? X times y. What is x? 2x. What is y? 3. And lastly, 3 squared. Simplify, and we just rewrite that. Good one, guys. Enjoy your home play. There is no tutoring today, by the way, because it's raining. Good one. Make it a family math night. Gather around, everyone. Let me show you what I learned. Bye.